Good morning. This is your stats sensei, Mr. Spensey, and this is our empirical rule assignment. And we'll also go over the standard normal using a calculator. So it was found that the mean length of 100 parts produced by a lathe was 20.05. So they're telling us our mean is 20.05 with a standard deviation of 0.02. That's important. Sketch the normal curve with Lay's mean and standard deviation that illustrates the empirical rule. We have to remember the empirical rule only applies to the normal distribution. It does not apply to any other distribution. So it only applies to the normal. So here we go. We're drawing our normal. We need to make it large so we can get all of our labels in. We need to remember that this goes from negative infinity to positive infinity. And I always want to start off with the z-scores. So my mean of my z-scores is 0. And we can divide this into 3 sections this way. So 1, 2, and 3. Positive 1, positive 2, positive 3. Then we go in the other way. We have negative 1, negative 2, negative 3. I should put that a little further out. So negative 1, negative 2, and negative 3. Between here and here, between positive 1 and negative 1 and positive 1 is 68% of our data. Between negative 2 and positive 2, we have 95%. And then between negative 3 and all the way out to positive 3, we have 99.7%. I'll label that off to the side. All right, so there we go. It says what percent of our parts are within plus or minus 1 standard deviation? Well, we know that that's always going to be 68%. If it's normal. If it's normal, that will always be 68%. What are the upper and lower bounds for within plus or minus 1 standard deviation? Well, now we need to go back to our actual values. Well, our actual mean was 20.05, and our standard deviation was 0.02. This means I'm adding 0.02 between each one of those. And over here, I'm taking away 0.02. But nonetheless, the spacing should be the same if I were actually drawing this accurately, and everything would be spread out nice and evenly. So it says upper and lower. We really should be looking at lower and upper. So if I take away 0.02 from 20.05, I end up with 20.03. And really all I did was go clear that. 20.05 minus the 0.02, and I got 20.03. So that's my lower bound. I'm going to label it L. I'm going to add 0.02 to this, and I get 20.07, and that's my upper bound. What percent of the parts were within plus or minus 2 standard deviations? Well, again, we're working with a normal, and the empirical rule applies, so this will always be 95%. So if we're working with a normal distribution, plus or minus 2 will always be approximately 95%. And we need to take away 0.02. Matter of fact, I'm just going to keep doing that and do all of these at one time. So this is 20.09. I added 0.02. I add another 0.02, and I get 20.11. Taking away, this becomes 20.01, because all I did was take 0.02 away. Take it away again, and I get 19.99. So what are the upper and lower bounds for parts within plus or minus 2 standard deviations? Well, plus or minus 2 is 20.01 to 20.09. We label that lower and upper. And then within plus or minus 3, that's going to be 99.7%. And that will always be that. And then what are the upper and lower bounds for parts within plus or minus 3? Well, the lower bound was 1999. Sounds like a sales commercial. And the upper bound was 20.11. We need to draw in our labels. So this is my lower, this is my upper, and that takes care of that one. The next thing it says sketch the graphs and find the probabilities for each and box your answers. Well, first off, it should have told us it was normal. It didn't. So I'm going to tell you that this is normal. All of these are normal, right? Because we're going to use the normal. Well, it asks for, this just P stands for probability. What's the probability of having a Z of negative 0.63? Well, one thing you have to know is the mean of all Z scores, the mean for all Z scores is 0 every single time. And the standard deviation for all Z scores is 1. Well, I still need to draw my graph, but I don't have to be nearly as precise as I was up here where I needed to label everything. So I'm going to draw my graph. We need to draw a graph every single time. And my graph, the mean, is going to be centered on 0. Well, I see that I have a negative, that's my Z-score, that's my mean. I have a negative 0.63, which means it's somewhere over here, and I really don't care exactly where. So I'm going to put 0.63 and label it as a negative. But it says greater, that means I'm shading up. And if I'm shading up, I'm going all the way to positive infinity. Well, this is a normal distribution, and we'll always use we will always use a normal CDF. Let me see if I can brighten this up. That'll help a little bit maybe. So second vars, norm CDF. We'll never use the PDF. And my lower, well, that's negative 0.63, negative 0.63. My upper was infinity, so 9.99. And since it's a Z-score, the mean is 0 and the standard deviation of 1, and it'll always be that way. Well, for showing my work, I have to write that down. So my work is norm CDF, lower, negative 0.63, upper, positive infinity, mean, 0, standard deviation of 1, and I need my labels. So this is lower, this is upper, this is mean, this is standard deviation. So now that I have that in, I'm going to just press enter a couple times. And I get 0.7356, so about 73.56%. So I'll box my answer, 0.7356. It's a little bit crowded here. I should have given you more space, but this is what we have, right? And that would be full credit. Well, the next one, it says, what's the probability, because P is probability, that negative 0.25 is less than Z is greater than 0.75. So they're telling me this is my lower and this is my upper, and we're working with the Z-score. All Z-scores have a mean of 0, standard deviation of 1. So I'll draw my picture. Centered on 0. Well, negative 0.25 is below 0. So negative 0.25, somewhere below 0, really doesn't matter exactly where. And then 0.75 is somewhere above 0. Again, I'm not too concerned exactly where it is. I just need to make sure that I have it. So there we have that. We're shading in between. That's what we're looking for. So I'm going to be going norm CDF, because that's where I need to go on the calculator, because it's a normal. The lower, negative 0.25. The upper, 0.75. Mean of 0, standard deviation of 1. And once again, lower, upper, we have to do the labels, mean, and standard deviation. So I'm showing my work. I've got all my labels in. Let's go to the calculator. Second vars, norm CDF, lower, negative 0.25, upper, 0.75, mean is 0, standard deviation of 1, because it's a Z-score, that'll always be that. And we can find out that it's about 37%. So 0.3720. We are always going to go 4 decimal places and truncate and box our answer. All right, so that takes care of that one. The next one, what's the probability that Z is greater than negative 1.06? All right. So I have a z-score. All z-scores are centered on 0. Negative, so I need to be on the negative side of the number line. So this is negative 1.06. And I'm shading up, and this is to positive infinity. So this is a norm CDF. The lowest part of my shading is negative 1.06. The highest part was positive infinity. Mean was 0 because it's the z-score and the standard deviation is 1. So lower, upper, mean, standard deviation. I have my labels. So second vars, normal, CDF, negative 1.06. 9.99, that represents our infinity in 0 and 1. We end up finding when we hit a pace a couple times, that's about 86%. So 0.8554. 0.8554. All right, the next one. We need a z-score between 1.06 and 4. Well, remember, 3 standard deviations is pretty far up there, so 4 is really far up there. So this is 0. This is a positive 1.06, so I need to be above 0. This is a positive 4, so I need to be above that. So that's our shaded area. Once again, it's normal because we're working with a normal. It's a CDF. This time our lower bound is 1.06. Our upper bound is 4. Our mean is 0. And our standard deviation is 1 because it's the z-score. So label them lower, upper, mean, standard deviation. And we plug that in. Second vars, normal, CDF, lower is 1.06, upper is 4, mean is 0, standard deviation 1, and we end up getting 0.1445, or about 15%. 0.1445. 4 places, truncate, box your answer. All right, so that takes care of that page. Moving on. A machine is set to fill Coca-Cola cans with Coca-Cola. Suppose that the amount per can forms a normal distribution. Well, that's important. You need to know that we're working with a normal with a standard deviation 0.03 and a mean of 12.05. So they say, all right, your standard deviation is 0.03, your mean is 12.05. Okay. Draw the label the graphs. Well, every time we have a normal problem, we need to draw a graph. That just needs to be part of our plan, but we don't have to be perfect. What percent of the cans will have less than 12 ounces? So first off, if I'm drawing my graph every single time, it's going to be centered on that 12.05. Well, 12 is less than 12.05, so that's down here. And we want to go, it says less than, so I'm shading this way. So my lower bound happens to be negative infinity. Once again, it's working with a normal. So this is a norm CDF. And this is going to be a lower bound of negative infinity. Upper bound of 12, because that's the highest part of our shading. Our mean is 12.05. And our standard deviation is 0.03. We need to come back and label those lower, upper, mean, standard deviation. There they're all labeled. And so now we can go to the calculator. And we can go ahead and press second vars, normal, CDF, lower, negative 9 raised to the 99th power. Upper is 12, mean of 12.05, standard deviation of 0.03. And we end up getting, oops, I did something wrong. I left off a negative sign because no probability cannot be negative. That's how I know I made a mistake. This needed to be negative 9. So negative 9 raised to the 99th power. And we end up with 0.0477. Remember, we're always going to go 4 places and truncate. So 0.04 0.77. Truncate just means to cut it off, and that's it. No rounding. The next thing, it says, what is the probability that a can of Coke would have more than 12.07 ounces? All right, so we'll go back. We always draw a graph. So this is 12.07. I mean 12.05 because that's our mean. Should label mean up there. And we want 12.07. So we're interested in being above it. So we're going to shade this way, which means we're going all the way to positive infinity. Once again, norm CDF. And we have our lowest part of our shading is at 12.07. Our upper part was positive infinity. We have a mean of 12.05. And we have a standard deviation of 0.03. So lower, upper, mean, standard deviation. So second vars, normal, CDF, 12.07 is my lower. My upper is 9.99. My mean is 12.05 and standard deviation of 0.03, which I already had in the calculator. And we find out that it's about 25%. So remember 4 places, 0.25, 24, truncate, and box your answer. What is the probability that a can of Coke would be between 12.04 and 12.07? Well, our mean is 12.05. Our lower is 12.04. And our upper is 12.07. And this is 12.04 is below 05. 07 is above 05. So this will be where we're shading. Norm CDF, lower 12.04, upper 12.07, mean 12.05, standard deviation 0.03, lower, upper, mean, standard deviation. So second vars, normal CDF, lower 12.04, upper 12.07, mean of 12.05, standard deviation 0.03. And we end up with a probability of about 0.3780. All right, that concludes scenario 3. Scenario 4. The heights of male adults are normally distributed with a mean of 1.7 meters and a standard deviation of 0.2 meters. You must draw and label the graphs for each question. All right, they tell us it's normal, so we can get to use a normal curve. We have a mean of 1.7, and we have a standard deviation of 0.2. So with that said, here we go. We always have to draw our graph so that we know where we are. It makes a huge difference on our success. So our mean is 1.7. And it says, what percent would you expect to have a height between 1.4 and 1.6? Well, 1.4 is less than 1.7, and so is 1.6. So both of these are below. So I need to be below. And I'm shading right there. Once again, they told us it was normal. So norm CDF 1.4 is my lower, 1.6 is my upper, my mean 1.7, my standard deviation is 0.2, lower, upper, mean, standard deviation. Second vars, normal CDF, lower, we said was 1.4 and upper was 1.6. So 1.4, 1.6, mean was 1.7. Our standard deviation was 0.2. And we find out about 24%. So 0.2417, and go ahead and box that answer. Next one, what is the likelihood that a male is taller than 2 meters? Well, once again, we draw our graph. Our mean is at 1.7. This is 2 meters, which is right here. And this is shading. It didn't tell us an upper bound, so it's shading to infinity. And so we're going to go norm CDF. My lower bound, the lower part of my shading happened to be at 2.0. We went to positive infinity. Our mean, oops, didn't need to write that there, is 1.7. Scratch that out, just write 1.7. And my standard deviation was 0.2. Lower, upper, mean. I did not like a mean, but a mu, and this is a standard deviation. So second vars, normal, CDF, lower was 2. Upper, we went to infinity, so 9.99. And there's our mean and standard deviation. And we find out about 7%. So in this case, 0.0668. The next one, what is the likelihood that a male adult is shorter than 1.2 meters? Well, we're going to be centered at 1.7. We have 1.2, which is below 1.7. And they didn't give us a lower bound, so that means we're shading to negative infinity. And I'm looking for this area right here. Still working with a norm CDF. Negative infinity is my lower. My upper is 1.2. That's the upper part of my shading. My mean is 1.7. And my standard deviation is 0.2. Lower, upper, mean, standard deviation. So second vars, normal, CDF, lower, -9 raised to the 99th. My upper, 1.2, mean, 1.7.2. And we end up getting 0.0062, which is less than 1%. So that's kind of a small percentage there. All right, moving on. Last page, which is scenario 5. Human IQ are normally distributed with a mean of 100 and a standard deviation of 15. What would you expect to have IQs between 60 and 90? All right, so we have a mean of 100. It told us it was normally distributed, so we can use a normal, and our standard deviation is 15. So there's our mean, and it says 60 to 90. Well, both of those are below it, so there's 60, that's definitely below it, and this is 90, that's also below 100. And so that sets up our lower and upper bound. So again, they told us it was normal, so a norm CDF. Lower is 60, upper is 90, and our mean was 100. And I happen to know that that actually is the IQ mean, and the IQ standard deviation really is 15. So lower, upper, mean, standard deviation. Typing that into the calculator. Second vars, normal, CDF is where we go to. And 60, 90, 115. So 60 is my lower, 90 was my upper. My mean was 100, and my standard deviation was 15. And that matches up with what we have drawn. Let's enter a couple times, and we find out that that's about 25%. So 0.2486. What's the likelihood someone has an IQ above 122? So our mean is 100, our standard deviation, our uh, starting point is 122. And they said above, so I'm shading up. So I'm shading to positive infinity because they didn't give me an upper bound. Still working with the norm CDF. My lower part of my shading is 122. My upper part of my shading is positive infinity. My mean was 100. And my standard deviation is still the same 15 that we've been working with. So lower, upper, mean, standard deviation. Second vars, normal, CDF, 122. We went to infinity. And that was our mean, and that's our standard deviation. So that looks like what I have drawn. And I have 0.0712. 0.0712. What is the likelihood that someone's IQ is below Forrest Gump, who in the movie had an IQ of 75? So mean is still 100. We're still working with that standard deviation of 15. The IQ of Forrest Gump was 75, so that's below 100. And they said less than or below, so that means I'm shading to negative infinity because they didn't give me a lower bound. So this is a norm CDF, lower bound negative infinity, upper bound 75, mean 100, standard deviation is 15. So lower, upper, mu, standard deviation. Second vars, normal CDF, negative 9 raised to the 99th, because that's my lower infinity. My upper was 75, mean of 100, standard deviation of 15. Paste that in there. And we find out that about 5% of the population, so 0.0477. Okay, that takes care of scenario 5. Scenario 6, the last one. The length of a pregnancy for the Asian elephant has approximately normal distribution with an average length of 609 days and a standard deviation of 31. What's the probability that an elephant's pregnancy lasts between 590 and 625 days? So there's my mean. So mu equals 609. Standard deviation was right here. It's 31. And they told me it was normal, so I can use the normal distribution. And that's important. We can't always use it. We can only use it if they tell us it's normal, or if we prove it, which we'll do later. So my mean is 609. And they said between 590 and 625. Well, 590 is below 609, and 625 is above it. So I have those values. So once again, a norm CDF, lower 590, upper 625, mean 609, standard deviation 31, lower, upper, mean, standard deviation. Second vars, normal CDF. What was my lower? 590. My upper, 625. Standard deviation, mean was 609. And the standard deviation was 31. And that ends up with about 42%, so 0.4271. What is the likelihood an elephant pregnancy lasts longer, so more than 644? A long pregnancy. You're talking about almost a year and 9 months. So 609 is my mean. Well, 644 is above it. They didn't give us a higher bound, so this has to go to positive infinity. So it's a norm CDF. Lower bound 644. Upper bound positive infinity. Mean of 609. Standard deviation. We're still dealing with the standard deviation of 31. They gave us that. Lower, upper, mean, and standard deviation. Second vars, norm CDF. 644 is the lower. 9, that's our infinity. And we find out that it's about 13%, so 0.1924. 0.1294. Lastly, what's the chance an elephant's pregnancy is less than 599 days? Well, less than means I need to be below. So this is at 599. So they didn't give us a lower bound, but 599 is below 609. So that's our graph. Norm CDF. Lower bound, negative infinity. Upper bound, 599. Mean of 609. Standard deviation of 31. Lower, upper, mean, standard deviation. I have my labels. We can go to the calculator now. Second vars, norm CDF. Lower, negative 9.99. Upper, 599. Mean of 609, standard deviation of 31. And we find out that that's about 37%. So 0.3735. All right. Thank you for watching this. That's the end of our video, and hope to see you on the next one. It's your Stat Sensei, and we are stopping recording.